Welcome to the BAFSA Official Observer Training. We're going to discuss a variety of topics. Firstly, we'll talk about badges and records, their history, and specifically their application to balloons, and also briefly other categories such as gliding, paragliding, and so on. We'll talk about the organization, how these badges are administered and issued, the sources of information that we as official observers need, the general principles that an observer operates by, the general procedures that we have to follow, and then balloon-specific procedures used when observing and adjudicating balloon flights specifically. Badges for ballooning come in three classes: silver, gold, and diamond. The entry level is silver. For a silver badge, one has to achieve a distance in a straight line of 100 kilometers, a duration of 3 hours, an altitude of 3,000 meters, and a target performance of less than 10 meters. The target has to be at least 3 kilometers from the takeoff point and has to be declared in advance. The gold is slightly more advanced. A 300 kilometer distance is required, a duration of at least 6 hours, an altitude of 6,000 meters, a target performance of 1 meter, and achieving 3 of the 4 gold standards can also be used to claim a silver badge. Finally, there are diamond badges which are issued individually on top of a gold badge, and the diamond performances are 500 kilometers in a straight line, a 12-hour flight, a 9,000 meter altitude, and 100 millimeter target performance. I might just mention that other than in gliding, the altitudes are actually absolute altitudes above sea level rather than an altitude gain. So in other words, you are allowed to take off in Gauteng and climb to 3,000 meters rather than as it is in gliding, where you actually have to gain 3,000 meters. The objective of these badges is to allow you to stretch your capabilities. And as you can see, achieving a distance of 100 kilometers is not trivial. You would have to have significant upper winds, perhaps at least 30 kilometers an hour or so, while also having sufficiently moderate surface winds that you can take off and land slowly. The duration is relatively achievable, I would say, with 4 cylinders in a relatively small balloon without too much loading. That should be achievable. Altitude of 3,000 meters likewise is not a huge challenge. A target of 10 meters is achievable, but maybe not on your first attempt. But I would say that especially when you get to the gold, the challenge becomes more significant. Achieving a 300 kilometer flight is definitely going to get your attention. 6-hour duration is probably doable with a medium-sized balloon and possibly just 1 or 2 people. 6,000 meter altitude already introduces complications because you will exceed flight level 120, which means that you will need oxygen. And 1 meter target performance, I probably don't need to say too much about. So the idea is to introduce a challenge, and in meeting that challenge, one is likely to learn some new capabilities. I've included this slide about gliding badges just for comparison to show that the challenges are very specific to the category. In gliding, the silver badge requires a 50 kilometer distance, a duration of at least 5 hours, and an altitude gain of 1,000 meters. Note that this is an altitude gain rather than an absolute achievement as it is in ballooning. Their gold badge requires 300 kilometers, still 5 hours, and an altitude gain of 3,000 meters, which now requires oxygen if you're not taking off at sea level. And their diamonds require either a 300 kilometer pre-declared route or a 500 kilometer straight line and a 5,000 meter altitude gain. Again, the diamonds are added to the gold badge. I may just mention that the maximum recognized achievement in ballooning is gold plus 3 diamonds. So even if you achieve all 4 diamonds individually, you are still only recognized as having achieved gold plus 3 diamonds, the highest recognized level, and only a handful of individuals have achieved those levels. In South Africa, there's only a single silver badge for ballooning so far. Dani Minnar achieved it using gliding observers, and as a result he was required to climb 3,000 meters rather than just to achieve a 3,000 meter altitude, which was actually unnecessary but imposed by the gliding observers. Airsport badges and records are recognized international by the FAI, the Fédération Aéronautique Internationale, which has several airsport commissions. Ballooning is controlled by the CIA, the International Ballooning Commission. I will not torture you with my attempt at the French version. Every country has a National Airsport Control, or NAC. In this country, that NAC is the Aero Club of South Africa. The Aero Club is responsible for member achievements anywhere on Earth. So even if a South African were to achieve a badge or a record in Europe, that record or badge would have to be administered through Aero Club. BAFSA is the section of the Aero Club that's responsible for ballooning in South Africa. The issuing structure consists of official observers. This is what you are hopefully going to become. The person who verifies that the flight actually took place as claimed and then submits that claim. The next person up the chain is the evaluator, who processes the claim and notifies the Aero Club and ensures that it is also notified to FAI. The rules are published in the Sporting Code. We'll discuss the Sporting Code at great length so that you know where to look for information, but it is a series of publications from the FAI that can be downloaded from their website at fai.org. Here are some general principles that we have to adhere to. Firstly, target flights have to be pre-declared before the flight. In other words, you have to declare up front exactly where you are going to drop your marker and hand it to the official observer, who will then ensure that the performance takes place as claimed. There is also an online declaration mechanism and a flight certificate. The flight certificate can be filled in just before takeoff so that the official observer can certify that the flight is actually taking place as claimed. Then a recording device. There must be a recording device to prove that the flight actually took place as claimed. Now, fortunately, the gliding world has already gone to great lengths to ensure that such recorders are available. According to FAI, the CIA must approve recorders. There are no such approved recorders, and so I think we can rely on the gliding world's hard work and use the recorders that they have approved. These recorders are defined on the FAI website, and it's possible to download not only a list of approved recorders, but also instructions on exactly how to download stuff, how to seal those recorders in such a way that they cannot be tampered with, and how to use them. Some of these recorders are matchbox size. If you can still remember what a matchbox looks like, the LX Calibri 2, for example, is literally about 50 by 40 by 30 millimeters or so, has an internal battery and is good enough to record anything that we are interested in. If the pressure sensor in the recorder is used for altitude performances, then that recorder must be calibrated either less than 5 years before the performance or within 3 months after the performance. If the barometric altitude recording capability is not used, in other words, one relies solely on GPS or GNSS more broadly, then calibration is not required. The observation must be by an appointed official observer. This observer must be appointed by the Aero Club through BAFSA in the case of balloons, and this person must witness the flight and personally download the recording from the recorder rather. At one end of the flight, typically the landing, the observer may not be present, and then witness accounts may be used. In our case, I would say that witnesses might be the recovery crew and things like photographs and possibly noting down the exact landing time and the exact landing location would be very helpful in verifying that the flight actually took place as claimed. In an FAI sanctioned competition, such as the Balloon Nationals in this country, competition officials can act as an official observer. This is a temporary appointment, which is only valid for the duration of the competition. The official observer must then submit the claim to the evaluator, who will further submit it to Aero Club and then to FAI. Now we get to the detailed procedures that the official observer must follow. These procedures are all defined in the FAI Sporting Code. There's a general section. The current version was published in 2018. You can download it from fai.org. Consists of 44 pages. It defines two classes for our purposes. Class A is free balloons and Class B is dirigibles and airships. Now, let's just look at a definition or two from the Sporting Code. General section. Firstly, an aircraft. Aircraft is a very wide term. There are two types of aircraft, aerodynes and aerostats. Aerodynes are heavier than air and aerostats are lighter than air. Aerodynes include aeroplanes, helicopters, gliders, hovercraft, and powered lift, whereas aerostats include, as we've seen, balloons and dirigibles. So the term aircraft is a very wide term which includes balloons and airships. Participation in records and badges requires a sporting license. In this country, the sporting licenses are issued by the Aero Club on behalf of FAI. They are recognized internationally though, so if you have a sporting license issued by the Aero Club, it is recognized in Europe or the USA or wherever else you want to fly. Holders must commit to abide by the Sporting Code. The licenses may be withdrawn by the FAI or the NAC, in our case the Aero Club. It allows you to represent your country in first category FAI events, and it allows you to participate as an individual or a team in second category FAI events. We'll define these events a little later. The Sporting Code defines various sporting events. Firstly, a national event, which is only for organizing NAC, in our case the Aero Club. Of course, BAFSA would in practice organize such an event. Then there's an international event, which is open to more than one NAC. Regional championships, either for a continent or for another region, such as perhaps Southern Africa. The World Championships, the World Air Games, which will include more than one discipline. In other words, there might be not only hot air balloons, but also gliding or paramotors or precision flying or aerobatics. And then multi-sport competitions, which includes not only air sports, but also dragsters or rifle shooting or synchronized swimming. There's an FAI sporting calendar on the FAI website. We previously referred to first category and second category events. We now define them. Of course, this is all information taken from the Sporting Code General section. First category events include the World Air Games, the World Championships, Continental Championships, international events approved by the CIA, and they're only open to participants representing an NAC. So in our case, they would be representing the Aero Club and presumably be given national colors. They must comply with rules in the Sporting Code. Second category events are other international events approved by CIA and may deviate from the rules in the Sporting Code, but those rules must in principle abide by the rules in the Sporting Code. In other words, there may be minor differences, but the basic objective must be the same. Participants must agree to abide by the Sporting Code, and all participants must comply with FAI doping, alcohol, illness and injury rules. Now let's talk about official observers. There are requirements in the Sporting Code General section. Firstly, OOs must be appointed by the NAC, in our case the Aero Club. They must know and understand the Sporting Code, and that's what we're trying to achieve right now. NACs must ensure that OOs qualify under these rules. There are temporary OOs that are appointed only for the duration of an event. Those are air traffic controllers who may verify takeoff and landing times, and competition directors and officials acting under the authority of the competition director if approved by the specific section in the Sporting Code, in our case section 1, which is the ballooning code. Two independent witnesses can make a written statement which must be countersigned by an OO. As I mentioned before, if the OO is not present at landing, for example, if you land in a field in the middle of nowhere, then the retrieval crew may be able to countersign or to make a written statement that can be countersigned by the OO. If an OO violates duty, in other words, breaks any of the rules around being an OO, then then the NAC must withdraw the appointment. Note that the NAC must withdraw the appointment. So if there are any irregularities, then that OO is no longer an OO. Recording during sporting events. In fact, records during sporting events, the organizers shall cooperate with the claimant to submit the claim. So this just imposes an obligation on the organizers to help the claimant to submit the claim to the relevant NAC and then to the FAI. The Sporting Code next discusses international records. These are world records, continental records, and of course there are national records too, and they adhere to similar principles. They're listed by subclasses as specified in the Sporting Code for the specialized activity. So in our case, that would be section 1, which describes aerostats. International records require a fee to be paid to FAI. I think it's in the order of €100 or so. Records may be held by a person, by a crew, or a team. If so, they will be listed in alphabetical order. And some of these record categories are only for an individual. In other words, only for one person. Records must be processed by the claimant's NAC regardless of location, as I said before. And in that case, the NAC is called the organizing NAC. if you fly the performance in another territory, the local NAC will supply the observers and then is called the controlling NAC. So the controlling NAC will submit the claim to the organizing NAC, and the organizing NAC will then submit it to the FAI. If an international record is at stake, the FAI must be notified within 7 days. The claim is then submitted to the organizing NAC. The full claim must be received by the FAI within 120 days. So, within a week, let them know, and then make sure that all the paperwork gets done within about 4 months. All these badge performances and records revolve around numbers. So how do we make these measurements? Firstly, everything is done in metric units. So altitudes are in meters and distances are in meters or kilometers. Speeds are in kilometers per hour. And the only exception is bearings or directions, which are measured in degrees and decimal minutes. They're not quite decimal because there are 360 of them rather than 400 in a revolution. Position must be determined by approved maps or GNSS. GNSS is the collective term for GPS and other similar systems such as GLONASS and the European system, and in our case mostly would constitute GPS receivers. Such GNSS receivers must use WGS84 Earth model, which is fairly standard in GNSS recorders. The time must be by approved timepieces or GNSS. Approved timepieces have to be calibrated up front and afterwards. And all times must be recorded in UTC. So in other words, if it happens at 1 p.m. on a Saturday, it is 11 UTC. But that's not a problem because by law, all activity in aviation must be recorded in UTC rather than South African Standard Time. Altitude must be done by approved pressure sensors or GNSS. Now, most gliding approved recorders have barometric capability. In the olden days, they used to have barographs with a huge roll of paper. But nowadays things are much more civilized with an electronic recorder with a pressure sensor. The little Colibri 2 that I told you about actually has a built-in pressure sensor, so it will automatically record your altitude every few seconds or however the sampler is set. If a barometric device is used, it must be calibrated either within 5 years before the performance or within 3 months after the performance. If both calibrations have been done, then the worst of the two will be used to determine the actual altitudes. If GNSS is used, an appropriate error margin must be included. So you can remember the figure 108 meters. That is regarded as the maximum error that the GNSS recorder will display in the vertical sense. And so if you subtract 108 meters from any altitude recorded by a GNSS, you are on the safe side. You must consult SC1 or the Aerostats section of the sporting code for exact procedures. Annex 4 describes distance calculations. Distances are actually determined according to a mathematical model known as the FAI sphere, which we will discuss again. And there is a distance calculator available on fai.org, into which you can punch your coordinates, and it will then tell you the official distance which was recorded along the surface of the FAI sphere. We've now concluded the general section of the sporting code. I would recommend that you spend a bit of time looking through it and making sure that you know where to find all this information. We now proceed to the sporting code section 1, which deals exclusively with aerostats. The current version is April 2021. You can download it from fai.org. It consists of 59 pages, so it's a bit bigger than the general section, and it defines all activities for Class A, free balloons, and Class B, airships. Free balloons consist of several classes, subclasses, and size categories. Firstly, the subclasses. We've said already that free balloons are Class A. The subclasses are AA, AX, AM, AS, and AT. All hot air balloons are AX, hot air balloons with heaters. Gas balloons, unpressurized gas balloons, in other words, ones where you can't really change the shape, are AA. AM is a combination of gas and hot air, or what we would call a rosier. AS is a gas balloon that has pressurization capability, and AT is anything else. For example, something that uses solar heating. There are 15 subclass size categories, 1 to 15. Most of the balloons we fly are sort of in the AX7 to maybe AX12 category. The limits are specified in cubic meters. Most South African balloons are specified in silly units, being thousands of cubic feet. Just as an example, any balloon from 78 to 106, in other words, from 78,000 to 106,000 cubic feet, are AX8. A 415 balloon is an AX12. To convert cubic meters to cubic feet, you have to multiply by 35,31. So for example, in the case of a limit of 2,200 cubic meters, you multiply that by 35,31 and then arrive at some sort of an answer that will tell you what the balloon's capacity in cubic feet must be. Gas balloons require conversion to compensate for the gas used. So if you're using hydrogen, you would use one conversion factor, helium as another conversion factor, and methane as a third conversion factor. And these conversion factors simply compensate for the amount of buoyancy produced by those gases, so that someone flying a helium balloon and someone flying a methane balloon are treated fairly. Airships are in Class B. The subclasses are BA, BX, BM, and BT, very similar to the subclasses in hot air balloons. BA produces at least 75% of its lift from a light gas. BX is a hot air airship with heaters. BM is a combination of gas and hot air, and BT is other, including something that produces more than 25% of lift by propellers or rotors or some other power source. There are 10 subclass size categories, 1 to 10. For example, BA7 or a BX3. And I'm not going to labor that point. Again, the limits are specified in cubic meters in civilized units. And if one uses strange units like cubic feet, one has to do a bit of a conversion, just like in the previous section. There are some definitions in SC1. Firstly, the definition of airborne. Airborne means no substantial contact with the ground or water. The balloon is considered airborne during momentary contact with the ground or water. So in other words, if you bounce on landing, you are still regarded as being airborne even though you touched the ground. You're also considered to be airborne when dragging a rope, as long as the rope is dragging freely on the ground or water. But the moment you moor, tow, carry, or get assisted by people from outside, you are no longer airborne. So as soon as someone grabs that rope, you are no longer airborne, even though the basket is not touching the ground. Flight is from takeoff to landing. So in other words, when you are airborne. A position checkpoint is defined as a point where the balloon can be proven to have passed over. but not necessarily declared. So in other words, if I declare that I'm going to fly from here to there, but in the interim I fly over a specific point either defined by GNSS coordinates or defined by a physical landmark such as a road crossing, then that becomes a position checkpoint. That definition is used later. Then they define an uncompleted flight. An uncompleted flight cannot be recognized for a badge or a record. And an uncompleted flight is one where there's been an accident with a fatality of any crew member within 48 hours. Or the pilot in command leaves the aerostat, or any part of the aerostat is jettisoned, resulting in a loss of control. So if the pilot leaves the aerostat and then the balloon continues for another couple of 100 meters, the entire flight is disqualified. Another definition is distance. Distance is the length of a great circle arc between two sets of coordinates on the FAI sphere. The radius of this FAI sphere is 6,371 kilometers, with a circumference of 40,000 kilometers, like the meter was originally defined. It does mean that distances, official distances, will be slightly shorter than actual at the equator and slightly longer than actual at the poles. Altitude is measured above mean sea level. Pressure altitude must be adjusted for pressure and temperature. And to be able to do that, you need the pressure at the surface and you need the temperature both at the surface and at the highest point. GNSS altitudes, we've already said, must be compensated according to a mathematical model that takes account of the differences between actual mean sea level and the sea level as contained in the WGS 84 mathematical model. Software is available on the FAI or through the FAI website. World records are not of immediate interest, but the same principles apply to local records or national records. So I'm going to briefly discuss them. There are two categories. One is general for any human being, and then female, where all the occupants of the aerostat must be female. Presumably someone who doesn't believe in binary gender doesn't qualify for the female record. These records are kept separately for every subclass and size category. So in other words, there are separate records for AX7, AX8, AX9, AX10, and so on. So if you have an odd-sized balloon, the world is your oyster. Altitude. As we said, altitudes are above mean sea level, but the altitude gain must be at least 50% of the claim. To say that differently, the altitude gain must be at least equal to the elevation of your takeoff location. If you take off from an elevation of 4,000 meters, then nothing below 8,000 meters will count. Distance, duration, and shortest time around the world, good luck with that one in a hot air balloon. And speed records, but only for airships. Then if you break a record in a small balloon and the record is better than the record for larger balloons, then your record also becomes the record for the larger size subcategory. So for example, if you break an altitude record in a 90, which is an AX8 balloon, then that will also become the record for AX9, AX10, AX11, and so on up to AX15, unless someone with a larger balloon has already exceeded that altitude. World records must be broken by a margin to make sure that it is indeed a new record and not just a measurement anomaly or just another pretender trying to emulate what someone has already done. In the case of distance, the previous distance must be exceeded by at least 1% or at least 1,000 meters. Duration and time must exceed it by at least 1% or at least 1 hour. Altitude and speed must exceed the previous record by at least 3%. No outside supplies are permitted while airborne, so you can't get fuel or food or anything from someone outside the balloon while you are airborne. Doing so violates or negates the entire flight. Air law and regulations, I would have said that it's pretty obvious that you're not allowed to exceed legal or regulatory limits, but the wording is actually a little different. You may not violate air law and regulations during FAI events, and you may not be convicted of infringement if that infringement helped outside an FAI event. So for example, if you try to break a duration record and you illegally fly into the night, then that would be an infringement that helped you, but would only be an infringement if you get convicted. So I'm inclined to say that we should voluntarily adhere to the principle that we don't exceed legal restrictions, regardless of being convicted or not, or otherwise one would have to make sure that someone gets convicted if they exceed legal limits during the flight. Accuracy. Distance must be measured to an accuracy of better than 1% and better than 500 meters. Duration and time, better than 0.1% and better than 30 minutes. Those limits are relatively easy to achieve using GNSS, but GNSS is not regarded as the primary means of measuring takeoff and landing times, as it's sometimes a little bit difficult to determine whether the balloon was airborne or not according to the airborne definition, and therefore observer or witness accounts are used, and the GNSS recording is simply used as verification. Altitude and speed must be measured to better than 1%. If measurements are less accurate, then you must use the most conservative value. So for example, if your altitude measurement has an error of 5%, then you should subtract the 5% from the measurement so that the altitude record is not possibly overstated. Accuracy may not be claimed better than the technology used to measure it. So for example, if you are using GNSS recording has a vertical error nominally of about 15 meters and a vertical error of up to 108 meters. You therefore cannot claim that you measured your altitude to an accuracy of 1 meter, because GNSS is simply not capable of measuring to that level of accuracy. If you're using a barometer, that's different, because the barometer may actually be classified as being more accurate than GNSS, and in that case it's permissible to state a more accurate tolerance. To submit record claims, you must use the claim forms in Annex E of Sporting Code 1, the one dealing with aerostats. These forms are compulsory for world records and they're recommended for local records, so there's no reason why we should deviate from them. The claim must be in English. Presumably broken English is also accepted. Must be sent to the FAI for ratification by the CIA. In other words, local records are maintained by BAFSA on behalf of the Aero Club, but they must be ratified by CIA specifically for world and continental records. Distance is between the takeoff point and the landing point. For really, really long distances, like flying to Australia, you are allowed to use intermediate position checkpoints. The spacing between them must be at least 3,000 odd kilometers apart, and the average spacing between them must be at least 6,700 kilometers odd. So this concession doesn't really help us on flights of less than, say, 20,000 kilometers or so. The duration record is the greatest time between takeoff and landing in a single flight. And further rules for airships and circumnavigation are not covered here. They're in the Sporting Code 1, but I don't think they're of immediate interest. And if they are, you can study them in Sporting Code 1. Sporting events are well understood in this country as they're presented fairly regularly. So I'm not going to spend time laboring the point, but I will highlight a few issues. For first category events, these are world international championships, as I've indicated before. There are experience requirements. The pilot must have been licensed for the subclass. In other words, AX or whatever. In our case, it would mostly be AX, at least 12 months prior to the competition. And they must have at least 50 hours of pilot in command time. For other events, which are CAI events, CIA events, pilots must have been licensed for at least 6 months and must have at least 25 hours of pilot in command time. However, to qualify as a CIA sporting event, there must be at least 15 competitors from at least 2 NACs. And in our case, that doesn't happen all that often. So I think even our national championships are not CIA events, and therefore there's no compulsory experience requirement. We've already listed the requirements for the silver, gold, and diamond badges, so I'm not going to do so again. Obviously, if you're going through the Sporting Code 1 with us, you will now see all the requirements listed, and they should be in accordance with the table that we've already seen. Claimants must be the PIC or the pilot in command on any flight claimed for a badge or a diamond. So you can't fly with your instructor and then log dual time and at the same time claim a badge. You may not have any licensed balloon pilot on board for a silver badge flight. So if you are doing a silver badge flight, you must be the sole occupant or your passengers must be unlicensed. On gold and diamond flights, you may have licensed passengers, but they may not hold the claimed badge. So for example, if you're trying to claim a diamond altitude, you may have another balloon pilot on board, but that balloon pilot may not hold a diamond altitude badge. Competition officials during national or international championships are exempted. So if the organizers send a senior balloon pilot with you who already has all the badges in the world, that's fine. He's not supposed to help you, he's just supposed to observe, and he therefore should not be an unfair advantage. Now, looking at gold tasks, we said before that you have to hit the target. How do you hit the target? Well, you drop a marker on the target, and this marker is specified. It must weigh no more than 70 grams, or the ballast head may not be more than 70 grams, and it must have a streamer made from nylon material of no more than 100 grams per square meter. That's very similar density to a normal sheet of paper, which is 80 grams per square meter. So that gives you an indication that it's a relatively light material, and it must be 1,700 by 100 millimeters. So it's a relatively large streamer, similar to sort of human height, and it prevents the little 70-gram weight from being thrown very far. So you basically have to drop it. You can toss it, but it's not going to go all that far. The streamer must be identifiable. The rules say that it must be signed by the OO and must be visible to him at takeoff. So in other words, it must be clear that you have it on board, that you are not getting your friend to drive to the target and drop it there. Competition supplied markers are permitted. So in the case of a competition, the marker will have a number on it which will be identifiable, and that is permissible. You may only claim one target or declare one target for a specific flight. So in the context of the national championships, if a specific flight involves more than one target, then you must pick one of them and your performance will be judged only on that specific target. I think we understand the principles now. So how do we do this thing? There's a checklist for records in Sporting Code 1, Annex 1. We can use this checklist unmodified for badge attempts. Before the attempt, you must study the FAI guidelines, namely the Sporting Code 1, and the list of world records, and the relevant forms. You must confirm with your NAC, in our case the Aero Club through BAFSA, that your OO appointment is valid. The NAC must inform other NACs whose territory will be overflown. So if you want to do something in Europe, the Aero Club must liaise with the local NAC. Timepieces must be calibrated for at least 3 hours. So in other words, you have to wind up the stopwatch and then check it against some official source of time for at least 3 hours. That must happen also after the flight, but this checklist deals only with before the flight. GNSS does not need to be calibrated because the time downloaded from the satellites is regarded as authoritative. You must check barographs and other recorders, see that they function, and see that you have their approval certificates, which, as I've said, you can download from fai.org, and that you know how to download the recording. You must check the passport and FAI license for each crew member, in our case, presumably ID and pilot license. If required, you must inspect the NAC permit. I don't believe that we have such a system in place, so we can do badge and records flights without prior approval from Aero Club. You must verify the volume of the aerostat by measurement or the manufacturer's type certificate. If you're using the type certificate, in other words, if you're saying this is a Cameron 90 and you're accepting it as being a 90, then you must verify its measurements against the dimensions specified in the type certificate, which would typically also be in the flight manual. So you would physically have to measure the envelope to ensure that it has not been modified. And then check with the NAC that the preliminary claim will be accepted. This is obviously in the case of a record, but it's worth just checking that what you're planning is going to be accepted. It would be a bit of a waste to do an entire flight and then discover that no one is interested. The checklist continues with activities on the day. Before takeoff, record the precise takeoff location on Form 3. Recheck the timepiece if used. Obtain the QNH. If a barometer is going to be used, set it to the standard setting, 1013,25 hectopascal. Check the recorder, start it, and seal it to the balloon. In other words, it must be attached to the balloon in such a way that the pilot can't smuggle it into someone else's hand and have them fly a helicopter with the recorder on board. Record the time and description of the takeoff. During flight, observe as much as you can. Obviously, if it's going to be a long distance flight, you may not be able to. In this regard, you could use electronic tracing stuff like hot air so that you are constantly aware of where the balloon is, even if you can't see it visually. Make notes of times, positions, and apparent height so that you have an ongoing record of the entire flight. Especially observe during imminent landings, because you may miss the actual landing because people disappear behind a tree or something. So if you have accurate positions and times just before landing, that can be used to verify the landing nicely. Landing, observe it if you can. The precise time and place must be recorded by witnesses, and again the retrieval crew might be useful in this regard. The official observer must interview witnesses if necessary. I might just note that another observer can serve this purpose. So the primary observer who observed the takeoff may rely on a secondary observer who observed the landing. One must then remove the barograph, stop the mechanism and keep the seal unbroken for the evaluator. For altitude records with a barograph, obtain temperature and barometric pressure at landing and temperature distribution in the atmosphere. The spot graphs on the Weather Service's website can be useful in this regard, but you should measure the temperature at that location and then obtain the distribution in the atmosphere somehow, for example, through a spot graph. The next section of the checklist is after the event. Write a report as the controlling observer. Explain why the claim appears to be valid. They call this a narrative, so write a little story. Don't duplicate information that's already on the forms. Just write a little story saying this person flew this flight, I observed it, it appears to be a valid claim. Complete all the forms and supplementary reports. Supply a map or plan showing the ground track. Recheck the timepiece over an interval of at least 3 hours if a timepiece was used. GNSS is exempted from this requirement. Arrange for analysis of a barograph. If a traditional barograph was used, an expert must interpret it and write a report. Check the finished claim file for completeness. There is a checklist in SC1. Authenticate all data relevant to the claim using experts as required. So if you're using some form of a recorder or there's some doubt about the distance or the altitude, you may have to consult an expert. If a world record is possible, file a preliminary claim within 7 days. Here's the content of the claim file. A contents page, forms 1 to 6 as appropriate. The controlling OO narrative, pilot information, this would be FAI license, pilot license, passport or residence evidence, and photo. Aerostat information, volume calculation based on the measurements you made, a drawing or illustration, technical description, registration certificate, and airworthiness documents. In our case, that would be an airworthiness certificate and a release to service, or an authority to fly plus a release to service. The flight itself, maps of takeoff and landing positions, scales, layout, of course, and specifically they want the coordinates to be distinguishable on these maps. Calibrations, reports, etc., depending on what sort of evidence you've used. If it's a barometric recording device, there must be a calibration certificate less than 5 years old, or the calibration must be done within 3 months after the flight. There must be assistant observer and witness reports, for example, where the OO did not witness the landing, and the narrative from the pilot. This is for interest only, but it could be nice to have a little story from the pilot explaining how the whole thing was planned and executed. A flight recorder is not necessary if the entire flight is observed by the official observer, but if any part of the flight is invisible or beyond reach, a recording is required. I would recommend using an IGC approved flight recorder. There's a list on FAI.org, and people have already taken the trouble to figure out that these things can't be tampered with and that they are reliable enough for the purpose. There's an approval document for each flight recorder, which the OO can use to verify its capabilities and also how to download the recording after the flight and verify its authenticity. The OO must verify that the recorder is on board at takeoff. It must remain sealed to the basket until removed by the OO. So the OO must satisfy himself or herself that this recording device actually accompanied the flight as claimed. And then the recording must subsequently be verified against actual observations such as the takeoff time, the takeoff position, the direction of flight, the approximate height, and so on, as observed by the OO, to make sure that the recording is an actual reflection of what really happened. If GNSS is used for altitude, you must subtract the error margin. If Barrow is used for altitude, the recorder must be calibrated within 5 years before the flight or within 3 months after the flight. If 2 calibrations are available, one before and one after, then the worst one is used for the claim. In other words, the error margin produced by the recording must be adjusted accordingly. Automatically calculated takeoff and landing times shall not be used because these times are calculated on speed or altitude, and in some cases the automatic approximation is not in accordance with reality. So real takeoff times should be used as observed by the OO or by witnesses consulted by the OO. If using a smartphone app, the OO must ensure that the recording is not tampered with. In other words, anything that's in a smartphone can be tampered with. And so one must make sure that there hasn't been an opportunity for the claimant to fiddle the recording. If GNSS altitude recording has been used, you must verify it against the standard geoid, in other words, to make sure that you're actually measuring above sea level and not only above WGS 84. There is a link in SC1 which points to unavco.org, and there is a standard geoid which shows actual mean sea levels, which you can use to correct the data as displayed according to WGS 84. I want to conclude with a few remarks. Firstly, if it isn't clear from the preceding, the objectives can be recorded one by one. So you can do your target on one day, your altitude on another day, your distance on another day, and your duration on another day. Each of these objectives is subject to observation by an OO and a claim to the verifier. The verifier will keep these achievements on record and then issue the badges as they become due. Previous achievements, you will hear spectacular achievements by fellow balloon pilots who accidentally circumnavigated the Earth one day long ago. Unfortunately, these spectacular achievements are not valid unless properly documented. So if there was an official observer present, or especially if the performance was achieved during a competition, then documentation may be obtained and obviously may be valid for a claim for a badge or a record. But until such time as the documentation is in hand, it will not count. As I said before, there is one silver badge in the country, and that's Dani Manar. There's an online OO quiz to verify that you know the sporting code. So once you've seen this presentation, you should be just about there. I would suggest just look through the other training material and make sure that you're fully up to speed before you commit to the OO quiz. You can contact me for further details and I'd be delighted to help. I'll send you a link as well as a pin, and you can then write the online quiz and we can discuss the outcome. Obviously, it's possible that my memorandum isn't perfect, and we'll sort that out as we go along. Once we've had a few people who've passed the quiz, we will approach Aero Club to appoint some official observers, and from that point on, the games can commence. We can all start pursuing some badges and hopefully learn some new tricks. So let's go forth and conquer.